Hi everyone, I am Balaji Chippada and welcome back to my YouTube channel. In continuation of our linear algebra, in this video, we will learn about equation of a line, equation of a plane, and a lot of small mathematics that is involved in these things. So without any delay, let's get started. In the previous video, we have learned about dot product and how you can calculate dot product and what is the generalized formula of a dot product, and then we have generalized the dot product if you have two vectors which is of column vectors, and you can call it as w transpose b or a transpose b. And we have also seen if we have two vectors, the angle between these is theta, and what is a dot b, modulus of a modulus of b and cos theta, and we can find the theta as cos inverse of a dot b by modulus of a into modulus of b. And then we have also seen that if dot product is 0, then both of these lines or planes are of perpendicular in nature. That is all we have learned in the previous video. Now we will learn a couple of things about equations of a line. So what we will learn? Equation of line. So let's say I have a 2D plane like this, which is x and y, clear? And let's assume I have a line like this. So this is a line. So in linear algebra or coordinate geometry, we usually represent the equation of line as y equal to mx plus c. And there is one more format which is ax plus by plus c equal to 0. And if I convert this, how I will convert ax plus by equal to minus c, by equal to minus c minus ax, and y equal to minus c by b plus minus a by b into x. So if I generalize this with this equation y equal to mx plus c, so this is minus c by b is my c component and minus a by b is my m component. So this can be generalized as mx plus c, clear? And this m is called slope of the line and this c is called intercept. And because we have axis x and y, we have y equal to mx plus c. What if I have axis as x1 and x2? I can rename the axis, right? So what I would do is this equation will become ax1 plus bx2 plus c equal to 0. Is that clear? And I can change this a and b with w1 and w2. Both of these are parameters and we call it as w0. So my final equation would become w1x1 plus w2x2 plus w0 equal to 0. So this is my equation of a plane in which it is of 2D and we call it as a line in which we have axis x1 and x2 and the components w1 and w2. You will learn all of these things in detail why we are converting into w1 and w2 in the later videos, and w0 is a constant value. So it is in 2D. And what we have been learning so far, now we have seen the equation of line in 2D, right? So what happens if we have the equation in 3D? So to visualize that, we will go to Google and we will Google 2D line, and I go on to images, and if you see, I have two axes and I have a line in between. And if I search for 3D plane, I will have three axes. If you see, I have x, I have y, and I have z, and I will have a plane. If you look at this one, a plane is a separation of multiple axes. It is little bit hard to visualize, but I am just showing you for an example. If you look at this one, I have xyz axis and this blue part is called a plane. So we have to take a line and extend it into multiple axes. That is when you will get a plane in 3D. Is that clear? So if I have 3D, I will have three axes, which is x1, x2 and x3. And as we have seen, every axis has a weight corresponding to it. So I will call w1, w2 and w3, and we have a constant value w0. So if we have to generalize the equation of a plane in 3D from a 2D, it would be looking like this: w1 x1 plus w2 x2 plus w3 x3 plus w naught equal to 0. So this is my equation of a plane in 3D. If it is in 2D, we call it as a line. If it is in 3D, we call it as a plane. So how do you visualize this? So let's say this is my x1 axis and x2 axis and x3 axis. Now I will have a plane separating these ones. So I will have something like this. So this is a plane which is going through all these axes x1, x2 and x3. So it is in 3D. Now we have learned that everything that we learned in 2D, we approximate to 3D and we approximate to ND. So what would be my formula of ND? Let's say I have x1, x2, x3 up until xn. So every one will correspond to w1, w2 up until wn. So my equation of a plane in n dimensions would be w1 x1 plus w2 x2 up until wn xn plus w naught equal to 0. Is that clear? Now if I generalize this, I can generalize this to w naught plus sigma I equal to 1 to n wi xi equal to 0. So this is my equation of a plane in n dimensional data. And usually we represent planes as pi as we go to n dimensions. So this is a plane pi which is of 3-dimensional data. Hopefully that is clear. Now let's take this notation, which is w naught plus sigma wi xi and I equal to 1 to n equal to 0. So this is basically what w naught plus, and we will convert into row vector and column vector. We have seen this in the previous video, x1, x2, xn, and this would be equal to 0. So given that w and x are column vectors, so we can say the equation of a plane in n dimensions would be something like this. And because w is a column vector, this is stated as w transpose. So what I can do, w naught plus w transpose into dot product of x equal to 0. So this is my final equation of plane in ND. So this would be my representation of planes, and we have a symbol as pi. Hopefully that is clear. And if you look at these two are vector representations. It is of shape n cross 1 and it is of shape 1 cross n. So this is a row vector and this is a column vector. We have seen the difference between row vector and column vector in the previous videos. Hopefully that is clear. If you have any queries so far, please let me know in the comment section below. I will reply to each and every one of you. Now let's take a 2D plane and let's draw the line equation like this. So let's say I have x1 and x2 and I have a line like this. So my line could be of any type and any shape, right? And this is my origin. So this length would be treated as my C, and the angle of this line, if where it meets, is called theta. So if I extend my x-axis and if I extend this line, this is called theta. And because this is a fixed line, even if I draw a line parallel to this at this point, this angle is also called theta. Hopefully that is clear. So this distance or the y-intercept, we call it as a y-intercept of a line from the origin is called C, and the angle at which it makes or meets the x-axis or x1 axis is called theta. And what we have, the equation w1 x1 plus w2 x2 equal to plus w naught equal to 0. Clear? So this would be converted as x2 equal to minus w naught by w2 plus minus w1 by w2 into x1. Hopefully that is clear. So this is representation of y equal to mx plus c. Clear? And here, what if my length of c is equal to 0? So if my length of c equal to 0, this line, the same line, would pass through the origin. Clear? Because this is 0, that means the distance of my y-intercept from the origin is 0. That means the line should pass through origin. Pass through origin. So here in this is the c component, minus w naught by w2 equal to 0. That means w naught equal to 0. So if my line or given plane passes through my origin, that means my equation would become w1 x1 plus w2 x2 equal to 0. If there is no constant term in your equation, that means the given line or the plane is passing through the origin of an axis. So what happens in case of 3D? If my plane is passing through origin, then my equation would be w1 x1 plus w2 x2 plus w3 x3 equal to 0. So in n dimensions, it would be sigma I equal to 1 to n wi xi equal to 0. So this is my generalized formula in n dimensions, in which if a plane is passing through origin, and most of the times we assume the plane is passing through origin to make the things simpler, so that we will understand the internal details more clearly. So what we have learned, sigma I equal to n to n wi xi equal to 0. So this is the equation of a plane that is passing through origin. But if you look at one, this is looking like a dot product, right? So let me go back and show you what is dot product that we have learned in the previous video. So if I show you this, I have two vectors a and b, and dot product of a and b is stated as sigma 1 to n ai bi. And if you look at this one that we have right here, which is sigma wi xi equal to 0. So this is the dot product of vectors w and x. So this can be written as w transpose into dot product of x equal to 0. Clear? And we have also seen that if dot product of two vectors equal to 0, that means they are perpendicular. Why it is perpendicular? Which is related to modulus of w into modulus of x into cos theta, and because it is 0, this theta should be 90 degrees. So let's assume if we have this one, that means I have a plane. Let's assume like this. So this is my x, and this w is a vector which is perpendicular to this plane. Clear? So this is w transpose usually. So w is a vector which is perpendicular to any given plane x if this plane is passing through origin. Hopefully that is clear. So we have pi, and the final conclusion would be if a plane is passing through origin, then the vectors are perpendicular. What are these vectors? W and x. Hopefully that is clear. I know this is a lot to take. In the next videos, I will explain why we are talking about this w and x and everything, because all the mathematics that is related to data science related to this part of this one. So we have seen, right, when we have different group of points, let's say this one, this one, this one, this one, this one, and I have another color of points like this. Let's assume like this. And what is our goal as a machine learning? We want to try to find the best fit line between these two. It could be this line, or it could be this line, or it could be this line, or it could be going from this origin. We don't know, right? So to understand which is the best fit line, we need to understand the equation of lines. And if we are talking about more columns, Then we have to talk about equation of planes. And we have seen what happens if we are going or passing the equation through an origin. So just to summarize what we have learned in the today's video, we have a 2D plane and we have a line in this 2D line, and the general equation is y equal to mx plus c, and the general equation is also like ax plus by plus c is equal to 0, and c is basically the intercept of y, this one, this is c, and I can convert this in this format. This is basically y equal to c plus mx, and instead of x and y I choose x1 and x2 because we will relate these things more when we are talking about data science. And I have replaced a and b as w1 and w2, and we call them as weights, and we will understand what these weights are in detail and what are its intuition. And we have the equation as w1x1 plus w2x2 plus w0 is equal to 0, and if we have n-d dimensions, we generalize into w0 plus sigma I equal to 1 to n wi xi is equal to 0. And then we converted this into vector multiplication. We have a row vector and the column vector, and we assume whenever we don't specify anything, both of them are column vectors. So this equation of plane would become w0 plus w transpose x equal to 0. And then we have seen what happens when a line or plane passing through the origin, this intercept will become 0. If the intercept is becoming 0, then the equation would become something like this: sigma I equal to 1 to n wi xi is equal to 0. But this is a dot product of w transpose dot x equal to 0, and if dot product of two vectors is equal to 0, that means they both are perpendicular. We have seen that in the previous video. If you have any queries, please check the previous video. So likewise, we have learned equation of a line, equation of a plane, and a lot of other things in this video. If you have any queries so far, please let me know in the comment section below. I will be happy to help you. And if you follow the next coming videos, you will be able to relate all of this intuition as well. If you learned something new from this video, a sub to the channel would be appreciated, and click that bell icon to get notified daily. And we will meet in the next video. Bye bye.